Welcome! In a previous video I talked about analyzing the Maze of Gradius, a game from 1987 for the MSX computer. In this video I will talk about a similar activity, analyzing Nemesis, also known as Gradius, whatever. I'll call it Nemesis as it is released for MSX, which is from 1986, so same period. And I have analyzed it in the same way, generated a map from the ROM image, and this time I will talk more about how I have done that, so my method for figuring things out and actually producing the output. So I hope you like it. The basic idea is that I will be looking at the ROM file and mostly the disassembled code in there, and I will obviously also find some data. But that I'm not really looking at, I'm mostly just parsing it with a program. So the idea is I'm looking at the code, how it's using the data, and I will then reproduce that in my own code, which reads the data from the ROM file to generate the output. Now, reading the code means reading the assembly, because obviously just the machine code, the actual numbers in there are very hard to understand. So I want to use a disassembler to read it in a slightly more readable way. And there's actually two disassemblers that I'm using. One is the one in OpenMSX Debugger, which is a really useful tool because it can show what is being run and go stepping through it and actually stepping back as well. Very nice. But downside of that is that it is not annotated. So it's really just the instructions. And that's all. It has some support for annotation, I think, but I haven't looked into how to make use of that. I think it was pretty hard to implement that in a way that was nice for me anyway. So I'm using an external disassembler, a Z80DASM, to disassemble. And that one can accept symbols and blocks files. So symbols will be used to give labels good names. And blocks files will actually be used to tell the disassembler that some block of bytes is not code but data, like byte data, word data. And it will then show it as data definitions instead of trying to disassemble it, which is also useful for readability, obviously. In the Maze of Gradius analysis, I've just disassembled the thing, and then I've used that as the source pretty much. I've edited it to add all my own comments about what it was meaning, what it was doing, and I modified the labels manually, which kind of works. But in this case, I thought it was nicer to get it to disassemble all the things automatically, to put the labels in and the blocks using the features of the disassembler. And that means obviously I should not edit it, because while I'm working, I'm adding labels when I find them and adding blocks when I find them. And then I want to regenerate the code or the file, the disassembly file. So that's what I'm doing. And that means that I should not be editing it, because then when I'm regenerating it, it will immediately lose all of my changes. So I have a separate file for reporting on the things that I found interesting. So that's the general setup. Now there's a little complication in that the file is not actually a single piece of memory. It has 16 pages of 2 kilobyte each, I think, and 4 kilobyte each. No, it has 16 pages of 2000 bytes hex each. And that is 8 kilobytes. I can't do math at the moment. Anyway, it has 16 pages, and they are all mapped in. Well, they are mapped in always at the same positions, so that makes it slightly easier. So there is at least an address where the data will be. But for example, page 1 and page 4 are mapped at the same place, so they share their addresses. So it's kind of hard sometimes You need a separate blocks file for each of them because the disassembler just won't accept to define blocks which are not in range. So that if you define blocks for page 2 and you're disassembling page 1, then it will break. And the symbols, actually, if you define symbols for page 1, then they will also show up in page 4. Which, well, I mean, if you know about it, it's not a problem. So I haven't actually tried to do anything about that. So my system now is that I have an editor. Vim is what I use. And there I have a hotkey for running make. So I just press F5 and then it runs make. That's nice. I can just press a single key. And when I run make is a program that actually can build do a compilation of a program is usually the idea. But you can run any commands. And so I've set up the make file, which describes what it should do, to actually run, to generate all the assembly files, disassembled files. So that's what I do with make. Then the nice thing is about Vim that when the file that it's editing is changed while you're editing it, it will actually tell you about it and say, hey, do you want to show the new version instead of what you're looking at now? And then you can just press L for load and it will load the new version. So if I have the disassembly open and I edit in a different window, I edit the symbols file, I press F5 for make, it will regenerate the file and then it will, I just need to press L and then all the new symbols are visible in the file that I'm editing. So that's really convenient and it works really well. So that's how I do this. I've shown the make file on screen so you can see the kind of commands. I'm not going to explain how it works exactly, but if you know make, then it's pretty clear what I'm doing there. So yeah, that's the idea, and I like it. It's a good workflow. It makes it possible to easily get an idea of what the code looks like with nice readable symbols once I have decided what they are, because obviously I still need to figure that out myself. To generate the map, my idea was to start to make a map of just knowing where the characters are, so that I could really draw it as a text file, pretty much. That's a nice idea. For that, I want to know, it's an MSX game, which means MSX1 has a name table. It's pretty much always a character screen. So I want to know when it is writing to this name table. So in the BIOS, there's a call to write to the video RAM, which is where all the video stuff is. So I've just put a breakpoint on there and checked when the code was actually going there. Now, I found a place where it was indeed writing to the name table, and as expected, same as in Maze of Gradius, it has a buffer in the main RAM where it stores the entire name table and it just copies it over to the video processor once per video interrupt, so once per screen draw. So that was exactly as expected, which means I have the video name table buffer, and in there I can put a watch point to see when it is written to. So I did that, and that way I found that it was writing, and why and how it was writing, and it turned out that it was getting the data from tiles, same as in Maze of Gradius, and I didn't really expect that actually, because in Nemesis, to me anyway, it doesn't really look like a tiled map. So tiles are 4x4 characters, and the entire screen, the entire level is made up of those blocks of 4x4, which means you would expect some sort of repetition. And I mean, if you know it's there, then yeah, you can see it. But it's not so obvious to me anyway. So they did that pretty well, because obviously they prefer if it's not very visible. And it's looking good. But so they have tiles, and I've been generating those tiles first to see what tiles are they using and how could they make levels from that. And actually, one thing that I found is that they have 2 different tile sets, because apparently one tile set, they use 1 byte to index, so it means maximum of 256 tiles in total, and that just wasn't enough to do the entire game. So several levels use a different tile set than others, and that way they have, twice the number of tiles, so 512, which apparently is enough to make the game. So that was interesting to see, and it seems to be pretty random. They just chose a few levels to give a different tile set, and in general it seems they've been pretty sloppy with the tiles. They've just made new tiles for everything. Well, they could have just chosen the characters carefully so that they could reuse existing tiles, but well, for some reason they didn't. More about the characters later, because there's a lot to say about those. Anyway, the tile sets, they are different for the 2 sets of levels. And another thing that I found, which is very interesting, I think, was that the level 6, well, that's no surprise at all. Level 6 has no tiles, because it doesn't really have a background. It's just, every level starts with a part of just stars and no other things. There's no tiles for that, it just fills it up. Level 6 is, the entire level is like that. There's just some enemies coming in, there's brain blobs with arms, and that's it. So they have no tiles, and that's pretty easy to understand. But what is not as easy to understand, at least I didn't expect it, is that there's another level with no tiles, which is level 3, the Easter Island level, with all the Moai statues. And there's no tiles in there. So I was first a bit confused, like how is that possible? Am I missing something? But then I figured out that no, actually there are no tiles. The entire level, all of the statues in there, the entire thing is just enemies. Every statue, including the rocket is on, is just stored as an enemy by the game. And so it just says, well, here's an enemy like this. And then the entire rock with the statue and all is shown on screen without having any tiles on it. So that was pretty interesting, I thought. So now I had found all the characters in the tiles, and I had found the tiles on the screen, and so I could just output them in a text file, or as text anyway, and then I could see if I had succeeded in building the level. And indeed I had. I could see level 1. Well, originally it went wrong for some other levels, but that was because they were using a different tile set. When I found that out, I could actually generate the output for all the levels, which isn't very nice. It's just a bunch of numbers, but it's still pretty clear that the output was correct, because the starry background was zeros with F7, I think, for stars. And then the walls were some other numbers. So it's pretty clear. You could see the entire outline of the level in there. So it looked like I had found the correct parts of the ROM file to make the map. And now all I needed to do was to actually generate the characters so that I could show it as images. So that was good. And step 1 complete. Then with the name table done, so I know which characters are where, the question is, what do the images look like, the character images? So, I have checked, and the way to check that was similar to the name table. I've put a breakpoint on the function for writing to VRAM again, and then I've checked where that happened. Well, it all looked very similar to the way it worked in Gradius. So it was writing, and then it was mirroring some things, and it was copying them. The copying is actually interesting, because the MSX, the screen it's using, screen 2, it has it is a character screen, so there's characters on it, but it actually has the shapes of the characters defined in 3 different regions. So there's the top, the middle, and the bottom, each of them 8 lines of characters. And the reason it does that is that it's possible that way to give every single character its own shape. which means it sort of works like, or it can be used kind of like a pixel screen where every pixel can have its own color, except there are some limitations due to the characters and how they work. But every character can have its own shape. And so that is interesting. It means it's kind of a graphical screen. That's how they present it as well in the documentation. But here we're using it as a character screen. But still, what it means is that if you define character 0 to be a certain shape, then that is just character 0 at the top 8 lines, or character 0 at the middle 8 lines. And so if you want the same shape for the entire screen, you need to actually have that shape defined 3 times. So you need to copy it over. That's exactly what happens in the Maze of Gradius. Everything that it defines, it will then copy to the other 2 areas, so that it doesn't matter where on the screen you put the character, it's always the same shape. However, here that is not the case. They actually make use of this feature, and that confused me quite a bit because I didn't expect it. But yeah, they can define a character to have a certain shape when it's at the top and a different shape when it's at the bottom. And so why would they do that? Well, because if you see the game, then often at the top the shapes are very different from the shapes at the bottom. So it makes no sense to waste characters on saying you need a different character for the top and for the bottom if you can just use the same character, because they're not going to be in the other area of the screen anyway. So what that means is that my code actually needed to take care of this, to separate the 3 areas and to make sure that when it was defined and when it's mirrored, that I keep track of where the source and where the target especially is, which area it's going to mirror to. And so after doing that, I got the characters nicely generated. Yeah, that was interesting. And then I got the good result, so that's good. Interesting thing to note, 2 things. One thing I noted was that when I was having the watch point on writing to the character data, I found the place where it is moving the stars. Now, what does that mean? If you play the game, you can see that the characters obviously will move 8 pixels at a time. And there's just no way around that. The screen is made up of characters. Well, there is one way around it. You can actually try to redefine the characters all the time, but it really cannot be done, because you would need to make characters which contain 2 different parts. So, well, the only way you could do it is if you have a very limited number of elements, and then you need to make characters for every transition. Practically, the game would get really ugly, because either it would get really boring, or, well, it just wouldn't work. So they don't do that, and the characters always move in steps of 8 pixels, whole characters, which makes total sense. The MSX2 has some way around it, but the MSX1 does not, so there's just nothing you can do. However, if you look more closely, the stars actually do move 1 pixel at a time. And so what happens there is that the stars are just a single pixel, and so they do actually update the pattern for the star. So the star is a single pixel, which is white, and the rest is black. And so every time they want to move it, they will just change the pattern so that the next pixel is light. And so that's a clever way to make sure it works. So they update the pattern. Now, when they're updating the pattern anyway, the cool thing they can do is they can make them blink. And as you can see, that's also happening. They are blinking. And so that makes them look more like stars, I suppose. However, what I found is that actually they are blinking wrong, so to speak. What I think happened is that originally they wanted to make them twinkle and well, really blink pretty fast, actually. And later they decided, well, no, it's actually better to make it a bit more slow. Or alternatively, they just made a mistake. Anyway, what happened is for the blinking, they have a table with numbers that say should it be on or should it be off. So when it's off, it's just the entire thing is black, and when it's on, you actually see that pixel, and the rest is black anyway because it's just a star. And that table is 8 bytes long, and so it just loops over it. It says it should be on and then off, etc. When it gets to the end of the 8 bytes, then obviously it goes back to the start because that's when it will go to the next character also, and then it restarts at 0. However, what they do is they say the position for this, they have a mask to get the position in the table, and the logical mask would be 7, which is just the last 3 bits of the position of the number, and that's not what it is. It is 6. And what 6 means, that is 110 instead of 111. So what it means is that if you have a position, the last bit is always set to 0, and in effect that means it's taking steps of 2. So it does 0, 0, 2, 2, 4, 4, 6, 6, instead of 0, 1, 2, 3, 4, 5, 6, 7. So it's just skipping half of the values in the table. And that means that it's obviously slower because it takes every value twice. And you can see that in the result. This is what it looks like normally. And you can also see what it looks like when I have the thing forced to 7 when I just edited the ROM file. So that was interesting, I think. That well, first of all, you can see they did this to make the stars move 1 pixel at a time, which makes them look very nice. But also that for some reason they they could have also, of course, updated the table to just put in the value so that it would be slower. But instead, for some reason, they just set the value to 6. As I said, maybe it's a mistake, maybe it's a choice that I thought it was nicer, and then it was like, well, this works, we don't need to update anything. So I don't know which it is, but yeah, this apparently is happening. Finally, what I found was that there was a place where they would send some, well, they would overwrite some characters actually. And it would be done if a certain value in memory was set. Now, I didn't really check what the value in memory was. Well, I did eventually, kind of. But I just first generated the characters, and it was these bells, which I thought I had not seen in the game, which is not true. I had seen them in the game, but I forgot. So what I did to check what exactly was happening when they were used is that I just set the value in that variable so that it would use them, because it would generate them if the value was set. And I thought, well, you know, I just run the game, I poke the value in there, and I'll see what happens. Now what happens is that your ship becomes a different shape, and all the power-ups become bells. And I immediately realized this as, oh right, I forgot. This is what it looks like when you have Twin B, different game, in cartridge slot B. So it's sort of an Easter egg for if you have the other game in slot B, then it would do this. So I did know that, but I forgot, and so I didn't recognize the bells. But yeah, those are that's what those are for, and so usually they're not actually used. But that value in memory is set at the very beginning when it detects the other cartridge in slot B. So that's it for the characters, and the result then is that I have a map of all the levels, well, the background of all the levels anyway, and it looks like this. So as you can see, very nice. Everything seems to work right. Actually, this is slightly better than it was, because here I have also scaled them to the right length, and there was some, well, I needed to find the length, obviously. For that I found some values which, well, where I found the length of the intro, then the length of the piece with characters. And so level 3 and 6, obviously, because they didn't have any tiles, they were, well, they just don't have anything there. But all the others I could generate that way. And so I got this nice background, which is what I was looking for as a start anyway. My goal with this project was to figure out the details about the secret levels, actually. So I thought it was nice to find all the entrances, even though they were already known. But I'd like to just show them on the map anyway. But especially to find all the bonus items in there. So the yellow and green power-ups for points and lives that you can find in the secret levels. However, I was distracted because I had a map and it was pretty empty. So I thought, how about the enemies? And I started with the cannons. So I looked at the way it worked, and I had this name table buffer that I used for finding the tiles. And of course, what happens is it first draws the tiles, and then on top of that, it will draw any enemies that are also characters, such as the cannons. So I set a watch point, and I went to a place where a cannon would appear. And pretty quickly I figured out how that worked. There was some code that would draw a 2x2 block of characters onto the screen. And well, when it was called for drawing a cannon, obviously it was then coming from a place where it was looking up where the cannons were. And so it wasn't very hard to figure out the cannons. So I got that, and I drew them. They were actually a bit weird. So the cannon table has 3 bytes for each cannon. And 2 bytes are just the horizontal position in the level, so on which character they are, which is pretty simple. But then the vertical position was in a single byte. And it's always at a multiple of 8 pixels, obviously. That means that the last 3 bits would always be 0, but they were not. They were used as flags for some other thing. Now, what were they for? The one flag is for saying, is this a cannon that is pointing up or pointing down? So is it on the ground or on the roof? Makes sense. There's one for saying, is this a red or a blue cannon? So does it or does it not drop a bonus item, a power-up? And there's one for saying, is the power-up blue or not? Well, that's what I thought anyway. However, it is not. What it is the top and bottom is correct, but then there's one for saying, does this one drop a red bonus or power-up? And the other one for, does this one drop a blue power-up? So the cannon is actually red. If any of those 2 bits is set, they are never both set. So that's just something to know. It's not really, it's just a choice, but it's just not a choice that I was expecting. I thought the color of the cannon would be in a single bit, but it's in 2 bits, effectively, because whatever the cannon is dropping, in both cases, it will be red. So that's it for the cannons, and after that I realized that this was a distraction because I wasn't actually planning on doing this, and so I did not look at the rest of the enemies. Might be interesting to figure them out, but for now I thought this was good enough, because what I was interested in was the secret levels and especially the power-ups in there. So that's what I did next. So then the next thing was the secret level triggers. Now, to find those, of course, I was using breakpoints again. So what I did was I first put a watch point on the level. The level obviously is just a byte in memory. I had found that early on because it's using it all the time to figure out which tiles to draw, etc. So I know where the level is. And so I put a watch point on that to see when is it writing to the level. At some point it was writing, which was after the high speed move through the entire level, just before starting the bonus level. So that was actually a bit later than I had hoped. But, it was still, then I found a different variable which was used to see that it was going to do the high-speed travel, and pretty soon I had found the place where it was checking that the ship was at the trigger location, so where you enter the level from. And well, it's pretty simple. It just says if you are here, then it triggers. Except for one. There's one, the third bonus level is actually pretty hard in the code. And that's also the one that is confusing to people sometimes because it's in one of those mountains that you can fly through. But sometimes it triggers and sometimes it doesn't. And I think people are aware of what makes it trigger, but I have just checked to see in the code how it works. And also I have tried to see if I could cheat, if I could somehow do stuff to make it trigger at times where I wouldn't expect it. But first, how does it work? Well, there is a level trigger or a secret trigger in levels 1, 2, 3, there's 2 in level 4 and 1 in level 7. And so how does it work? Well, in level 2, 3 and 7, they are just normal and they just trigger the secret level and you go there. Levels 1 and both of them in 4 are different. They're all inside the tunnel through the mountain. And they actually, when you go there, when you go through, they increment a value. So there's a count that counts how many times you have already hit one of these. It doesn't care which one, just how many times have you hit it, or have you hit one. And if the count is 3, in other words, if you have hit all 3 of them, then you will go to the secret level. And so what it means is you need to fly through all 3 of the tunnels. So if in level 1 you have not flown through the tunnel, or in level 4 you have not flown through the first tunnel, then in the second tunnel you will not go to the secret, and if you have, then you will. So the cheating ways, well, one way you could try to cheat is that you just fly through the same tunnel several times. That doesn't work because it has a value that says what is the last tunnel you have hit. And the tunnels are called 2, 3, and 4. All the others are named 1, which doesn't really matter because they don't look at the value. Well, they look if it's not 0. But these are 2, 3, and 4. And if you hit it while it is the same value as the one you hit, then it just ignores it completely. It says, well, you're just flying through it a second time. You're just going back and forth. And I think even you are still in it. So otherwise it would just hit it several times immediately. So to make sure that doesn't happen, it will only react on a different tunnel. So if you hit 2 first, then you hit a 3 and it says, this is a new one. Then you hit 3 again and it says, well, this is the same, so it doesn't do anything. So you need to hit 3 different tunnels in a row. So yeah, there's not really much you can do there. The only other thing I could think of that would be possible to cheat would be if you, for example, first you skip the tunnel in level 1, then you go through both of them in level 4, and then after the game ends, well, when you finished it, you start on level 1 again, then you go through the tunnel on level 1, but apparently, I checked, at that point the counter is reset, and so it will not take you to the secret level, because that would actually be interesting. That would mean that it would take you from level 1 to the secret level, and then it would probably take you back to level 5 after you exit, because that's what you go to after the secret level. But, well, the cheating didn't work, so they apparently did it right. And no way to get around it as far as I could see anyway. So I've drawn the entrances on the map as rectangles, and then the only thing left is to figure out how it works inside the secret levels, and in particular with the bonus items, because that's what I was interested in. So the bonus items in the secret levels are very similar to the cannons. I could also find them in a similar way by looking at the name table, obviously, with a watch point. And they also have 3 bits to say what kind of items they are. So why 3 bits? Well, there's actually 3 different types of bonus items. So they have one of these bits. They define it with those bits. There's one bit which says if it is hidden or not. So if it's hidden, it means it's not shown until you shoot the thing around it or over it. So you have these balls, and when you shoot them, they appear. So that's one of the bits. Then there's one, I thought, for saying if it's yellow or green, but no, actually there's one for saying it is yellow. It is points or alive, well, whichever one. And the other one for saying, no, this is not a regular points or life item. This is a repeating points item. So if it is a repeating points item, what that means is when you pick it up, it will actually reappear, and you can pick it up 8 times in a row until it's finally gone. Yeah, that's the different types of bonus items that exist. And so using that, I could make a map with a whole bunch of bonus items. And so it looked really good, and I was happy, and I was ready to make the video. But I also, just for fun, played the game again. And then I saw that it didn't actually look exactly the way that I expected it to. So what was wrong? Well, there were actually 2 things. One thing was wrong, and the other thing just surprised me. What was wrong is that in the game, there's actually not as many bonus items as there are in my generated map. So that's really weird. And I thought, how is that possible? What is happening? So I checked it out. And the other thing is that the points for the bonus items, well, it starts with 100, then 200, 500, 1,000, 2,000, 5,000, and so on, until it's 10,000 for each item you pick up, and then it remains 10,000 for each next one. Except sometimes it suddenly drops back to 100. And so I wanted to know how that was happening. So both of those things I have been looking into, and they have been interesting. So first, why are there items in my map that are not in the game? Well, the answer is there aren't. So that's interesting. If they are in the game, then why don't I see them? Well, the answer to that actually is not very hard. It's a technical thing, but it's also an interesting thing for gameplay. So what's happening is that for the enemies, and weirdly enough, these bonus items are counted as enemies. So they are similar to the enemies in that they appear on the screen, and then you can interact with them. These enemies, you can shoot. Your bullets go right through them, and your lasers as well, obviously. But you can hit them, and then something happens. And the something is not that you die, but it's just that you get points or life. Technically, it's really easy to make that the same as enemies. And so that's what they did. But what that means is that they are stored in the table of currently active enemies on screen. And that table is very limited in size. So there's only a very limited number of enemies that can be on screen. And when it's full, then it's full. And when a new enemy needs to be created, but the screen is full, then that enemy is not actually created. It's just left out. And so that's what happens. When the screen is full, then there's a new bonus item that might appear, and it doesn't because the screen is already, all the enemies are there. So that's the thing there. What it means, obviously, in terms of gameplay, as I said, is that if you want maximum points, then you are going to need to pick up these items really early because there's a lot of them. And if you're not fast, then some of them will just not appear. So that's an interesting thing to see if I can maybe, or someone else, can maybe do a playthrough. I would suggest tool assisted, so with the emulator going one step at a time. So every move is perfect. And to see if you can pick up every bonus item there is, and so lose nothing through the fact that it's not generated or not created on screen. So I think that's actually a pretty interesting challenge. So I might try that myself, but I would also encourage anyone else to do it before I do. Now the next thing is similar. It's also something that you would need to use in gameplay, which is avoiding the fact that the scores reset from 10,000 to 100, because obviously that costs a lot of points. Now, when does it happen? Well, it happens, I have found, when a bonus item is not picked up, when it leaves the screen and before you picked it up. So then you obviously can't pick it up anymore. But so when you lose a bonus item that way, when you just missed it, then your score goes back to the start, so to 100 per item, well, for the first item. And so having that happen is really expensive. If you go for a maximum score, then you would expect that you're going to pick up a lot of bonus items. So all of them are worth 10,000 after the first 7. And so the first one you miss, so that costs you 10,000 points. But then the next one is only worth 100, so that costs you 9,900 points. Next one is worth 200, it costs you 9,800 points. And so on, until you have 7, and then the next one is finally 10,000 again. So in total, you're losing an enormous amount of points through missing just a single bonus item. So if you want maximum score, again, that is an interesting challenge. You need to pick up everything. I found that you do only need to pick up the visible ones. So if you're missing one that you haven't revealed, that is still hidden behind the balls that are on screen, that's not a problem. In those terms, it's okay to miss something, but anything you can see, you must pick up, or else you will suffer the consequences. I think it's interesting in the same challenge to see if it's possible to actually reveal and pick up every single bonus item, and also make sure every possible bonus item is actually created on screen. I'm not even sure if it's possible, but it's definitely interesting to see and to try, to just see if it's possible. So that's an interesting challenge, which I might attempt, and I would definitely encourage anyone else to attempt it as well, because I think it's a lot of fun. So that's what I found for the bonus items. That's it for this video as well. So the map that I've generated now has all the bonus items in it. It has the cannons in all the levels, but it does not have any of the other enemies. So there's actually some work to do if you want these maps to be complete. And I've talked about how I did this, and I would encourage anyone to continue this work. So I've put the code on GitHub so that anyone can check it out and repeat it or improve on it. So please send me a pull request. That's how you add improvements on GitHub. If you've made some improvements to it, that would be really interesting. Also, of course, the algorithm here really likes it if you put stuff in the comments, so please do that as well. And of course, like and subscribe and all that sort of stuff. You know how it works. I really appreciate that. I have to say, I think the algorithm probably prefers liking and subscribing. Personally, I prefer comments because I just like to hear what you think about it. Please let me know. That's it for now. I think I will probably do something similar in the future, and probably I'll be a bit faster, because in this case I had some technical problems and other things to do and distractions, which made it take really long before this video was finally done. And actually I'm not sure how soon the next one will be done either, because I have other videos that I want to make and other things to do. If you want to see something, please let me know, and if I find it interesting, that might be a motivation for me to make the video sooner, obviously. Thank you for watching, and I hope to see you, I hope you see me in the next video. Bye.